Hi, today we'll be solving the question 2 of homework 2 for our probability homework. So the question gave us the probability density function fx, capital X and x. That is three values in three regions. When x is equal to 0, it is a into e to the power minus 2 del x, that's the impulse function. When it's between 0 and 1, 0 not included, 1 not included, it's e to the power minus 1 into e to the power x plus e to the power minus x. And in all the other regions it's 0. So the first part of the question says that we have to actually find the value of a, that's the constant in the first part when x is equal to 0. So for that we have the it's a property of probability density function that the area under the entire curve that should be equal to 1, because the density function shows us the probability that the number of times each probability can come up, so the sum has to be 1. So now for that we have the following, which is that now we see from minus infinity to infinity we have this whole range, but our function only exists in these ranges. So the area under the 0 to 1 curve, that's this, we simply integrated from 0 to 1, right? So e to the power x will remain e to the power x on integration, and e to the power minus x becomes minus of e to the power minus x. So when we multiply that with e to the power minus 1, we get this. We will apply limits of 0 to 1, which upon simplifying cancels out e to the power minus 1, positive, negative, e to the power 0, that will become 1, and then we have minus of e to the power minus 2. And except for that, we have this term, a e to the power minus 2. This comes from this term, the one where x is equal to 0. However, what happens is that the del x that we have, upon integration it becomes 1, so we can not consider it. But need the area under the curve, so we have to take the sum of this, which does not include 1, and also the point under 1, so we add this too. So now we know that the sum of this entire term has to be equal to 1, right? So these two cancel out, this turns out to be 1. We get this down here, a to the power minus 2, this entire thing is equal to 1. 1 cancels on both sides. We have a e to the power minus 2 is equal to e to the power minus 2. Hence we get this, a is equal to 1. That's our first answer. Secondly, we have to sketch the probability density curve. Now, we can simply put in the values from the equation above and plot it. So when we do that, when we put the value of a when x is equal to 0, so that's exponential to the power minus 2, that value is 0.135. So when x is equal to 0, that's x is on this axis, and this axis is the probability density function. Over here we know that the value of x is 0.135, and when we plot this part that's between 0 and 1, we get an exponential function which starts at 0.735 and it ends at 1.135, but actually it exists only between 1 and 0, so it never goes to 0 or to 1. That's the second part. That's the sketching of the probability density function. The third part, which says, is that we have to actually write the probability density function in one line using step functions only. So for that, we have the density function we can write is equal to, when x is equal to 0, we have a e to the power minus 2, which is the same as a is equal to 1, so e to the power minus 2, 0. Plus, we write the expression e to the power minus 1. We change the terms from x to n because we have this entire thing in n, right? So we have e to the power minus 1 bracket en plus e minus n, and this entire thing into our step function only when n is greater than 0. This is because at n equal to 0 the value is this, and when n is greater than 0, then we have this value, right? However, we can write in another way that can be given as we can write the same thing like when it is between 0 and 1, we have e to the power minus 1 e power n plus e power minus n into this unit step function, and we can write an impulse function as the differentiation of a unit step function. So we can actually write that now when we write this part, we mean that at the origin when n is equal to 0, we have this value of the amplitude. However, at n x is equal to 0, right now as n is equal to 0, our value is just e to the power minus 2. So what we do is we take out the part that is between e to the power minus 2 and e power minus 1 into e to the power n plus e power minus n. And we get that difference in between. So we just subtract the difference from the entire one. So we'll just get e to the power minus 2 when we solve this portion. And when we get differentiate this over here with respect to n, this will become your impulse function, which will be the value at n is equal to 0. So that's the third part. The fourth part is that we have to find out the probability distribution function from the density function in analytical form, that is not in a graphical form. So now we know that the analytical form, that is the probability distribution function, is simply the integration from 0 to x of the density function. So we just change the density function into a variable t from variable x to avoid confusion. By doing so, what we get is from 0 to x, we are integrating e to the power minus 1, e to the power t plus e power minus t dt. Upon integrating, we get this e power minus 1, e power t. Because of minus t, when we integrate, we get a minus e power minus t from limits 0 to x, 0 to x. Upon putting in the limits, we get e power minus 1 into e power x minus e power minus x. So now we know that the probability distribution function is equal to this value, but this is only when x is in between 0 and 1. So we get this value when x is in between 0 and 1, and when it is equal to 0, we know that because a is equal to minus 1, so this will be equal to e to the power minus 2, right? Yeah. And lastly, we need to get the sketch of the probability distribution function. So for that, now we know from the previous one that when x is equal to 0, we have this value, which is 0.13. So we can plot when x is equal to 0, 0.13. And from this, we actually get the value of 0. We then put in the value of 1. Also, we need to know that the probability of the probability distribution function can never go greater than 1, because it's actually a plot of the probabilities. So we see that we plot both at 0 as well as a 1. So we see when we plot at 0, it goes down to 0, and when we plot at 1, x equal to 1, we get 0.86. As it's an exponential function, hence we get this shape. So the line that has been highlighted is the graph of the probability distribution function. And that was the question. Thank you.